Take a look at scientific notation and then we'll use it for calculations. And we'll find that calculations with scientific notation are essentially an application of the rules of exponents. Let's start by deciphering what's going on in this slide. So generally, let's just draw an example of what scientific notation might look like. It might be the number 2 times 10 to the 6, or 1.5 times 10 to the negative 3. So we've got some value, p, where p is a number between 1 and 9. And that's the number in front of the decimal place. So we don't want to use 10 and we don't want to use 0. And then we multiply that by 10 raised to the power of some integer. Of course, exponents don't have to be integers. This is just for scientific notation. And then the key is to be comfortable converting between ordinary numbers like 1,562 and scientific notation, which would be 1.562 times 10 to the 3. So we'll look through these steps, we'll look at what these steps means by doing some examples. Let's convert this first row of numbers written in ordinary or decimal notation to scientific notation. So for 34,000, remember that we've got a decimal point here, and we want the number to the left of the decimal point to be a number between 1 and 9 inclusive. So I'm going to pick it up and move it until only the 3 is to the left of the decimal. So that involves moving it 1, 2, 3, 4 place values. Written a little bit larger to make it easier to see, I'm taking the decimal and moving it 1, 2, 3, 4 spots. So my new number is 3.4 times 10 to some integer. Now I need to make sure that this 3.4 times 10 to an integer is the same value as 34,000. So I think about how many spaces I've moved my decimal point. I've moved it 4, so I know that I need a number 4 up there. And then the question is, did I move it to the left from its original place or to the right? If I move it to the left, I'm going to have a positive number here. I have a hard time memorizing rules like that, so I prefer to think of it this way. Well, 10 to the power of 4 is a large number. 10 to the power of 4 is 10,000. And I want 3.4, a relatively small number, to be a large number. So I know that the 4 needs to be positive. Similarly here, 62.8, well, the decimal isn't quite in the right spot for scientific notation. I'm going to move it 1 to the left, so I only have a 6 to the left. So I have 6.28. And is 62 a relatively large number compared to 6? Absolutely. So I'll raise it to the power, or I'll take the 10 and raise it to the power of a positive exponent. And in this case, just to the 1. For 0.00503, I'm going to pick up the decimal place and move it 1, 2, 3 spots over to the right this time. So I'm taking a relatively small number, 0.005. I'm making sure that I have only one number between 1 and 9, in this case a 5, to the left of the decimal point. So I have 5.03 times 10 to the power of 3, because I moved the decimal point 3 spaces, 3 powers of 10. But this time, because I moved it to the right to get from the original to scientific notation, I'm going to raise it to the power of negative 3. Again, another way to think of this, 10 to the power of negative 3 is 0.001, or 1 over 1,000, 1 over 10 to the power of 3. So that will in fact take my 5 and turn it into this small number, 0.005. And finally, 4,000 will be 4.000 possibly times 10 to the power of 3, or 4 times 10 to the power of 3. We actually already saw this issue in the very first example, only we didn't address it there. With a number like 4,000, we don't actually know whether those zeros are significant. If we know that all 3 zeros are significant and should be included, then we'll write our answer as 4.000 times 10 to the power of 3. But if we're not sure, then it's safest just to write the number as 4 times 10 to the power of 3. This has only one significant digit, while this has 4. So it's safest, if it's unknown, to use only the non-zero number, as we did with the first example, 34,000. If you do know how many of those digits are significant, then you can write the appropriate number of zeros. So for us, because we have no additional information, this will be the correct answer. But the reality is that this may well be what's being sought after. In any case, that's beyond the scope of this discussion. So now that we can convert to scientific notation, I think it's a little bit easier to convert from scientific notation. So we have 8.06 and we're asked to multiply it by 10 to the power of 3. That means we pick up the decimal place and move it by a factor of 1,000, 10 to the power of 3. 10 to the power of 3, 1,000 is a big number, so I need to make 8.06 into a larger number, so I'm going to move the decimal place to the right. So again, I'll write the original number and add some zeros that I might need, and then I'll pick up the decimal point, move it the desired, the indicated number, and that's 3. 1, 2, 3 spaces. So in ordinary notation, in decimal notation, this number is 8060, 8,060. If I'm being asked to multiply by 10 to the power of a negative number, I'm going to pick up the decimal place and move it to the left. Again, you might want to indicate, add a couple zeros just for yourself so that you know how many spaces you're actually moving, just to help you keep track. And I'm going to pick up that decimal place and move it 2 spots to the left. So I'm left with 0.011 or 0.011. Adding zeros can be especially important when a number looks like this, just as you're getting the hang of it. So I'm going to write 6.8 and then just continue to write zeros to make sure I have enough, because this is a very large number. I'm being asked to create a large number, multiplying by 10 to the power of 7. So moving that decimal place, you do 1, 2, 3, 4, 5, 6, 7, or 1, 2, 3, 4, 5, 6 additional zeros. So I have 6, 8, and then 6 additional zeros. When we write it by hand, we often group these zeros in groups of 3 just to make it easier to read the number, but it's not required. Generally, we don't use commas, but you will see that as well. But mathematically, we tend to avoid that. And this final example, I'm again going to add a pile of zeros, this time to the left of the 1, just because I know that I'm going to move my decimal place over to the left. So it's to the right of the 1 at the moment, and I'm going to move it 5 spaces. 1, 2, 3, 4, 5. So that gives me 1, 2, 3, 4 zeros, and then a 1 to the left, or to the right rather, of the decimal place. Use whichever tips and tricks here help you to convert between scientific and ordinary notation.